So at the request of one of my subscribers, we are going to do some BMS testing. This is a Daly 7S BMS with balance, rated for 30 amps. And we are going to do some testing on this BMS. Now, for the sake of speed, I am not going to use a large pack like this to do any testing. I am going to use a single cell 7S pack to do testing with. That way I can charge, discharge, and balance this quickly for the purposes of this video. So we are going to use this 7S pack here. I was just gooping some hot glue on it just to hold it together, just for testing purposes. And I would spot weld it, but I literally blew up my spot welder, my second one. I ordered a replacement for the first one I blew up, and I installed the capacitor backwards and immediately blew up my second spot welder. So I have no spot welder. I have to order a third spot welder. Anyways, in the meantime, I can actually just do a quick solder job on this, and I'll just solder the links, solder the BMS on, and we will do some testing. But this is going to be my test rig, and I'll get it set up. Okay, let's start to wire this up. Your BMS is normally attached on the negative, so here is my negative, here is the BMS. You can see it says battery negative here. That's power negative, so that'll be lead out to whatever you're going to power. This is your battery negative, so I'm going to attach it here to the negative here. Okay, that's good. Yeah, I've got to grab it. I quickly grabbed an XT60. I'm going to put the positive on the positive here. Okay, and then this will actually, this negative will actually connect to the BMS here to complete the main circuit, and I need to wrap this in some electrical tape here. And I'm just doing this temporarily, purely for testing purposes. This is not how you solder. This is not how you do things. This is just a quick test rig that I hope, and I'm just doing enough to not burn the house down. Okay, so we have a, we have an XT60 that we can now use to power things. Now I need to attach the balance leads. So like I said, you start from the negative, and I'll attach this to the negative. Okay, that is attached. Then you move up to the second most negative, goes to the positive side here. Okay, and then the next most negative here goes to this side of the connection here. Okay, then the next most negative comes up to this side of the connection. And you might wonder to yourself, does it have to attach to the positive or negative? It does not. These are linked. So you're actually attaching the BMS wire more to the link than to the positive. So this wire could have attached there or there. It would not have mattered. You're just the BMS wire is attached to the series links on either the negative or the positive of the series link. Okay, that is wired up. It is not pretty in the slightest, but if we've done this right, then this should power up and give us our individual voltages. It has, and hopefully you can, let's see if you can see that. Oh, pulled my camera down. Let me reset. Okay, fix the camera. Okay, so this rig is set up. The BMS is in place over here. Here you can see the ISDT is reading all the batteries. I just chose random cells out of my pack. Out of my battery, box. So they are not fully charged. And that's good because one of the things we want to check is the balance capability of the BMS. So first thing I'm going to do is I am going to charge this pack up and we'll see if the balance kicks in. Now, you should know that the balance on these BMSs only kicks in above 4.18 volts. And my BMS, my power wall, I never charge it to 4.18 volts. I always charge it up to about 4.15 volts. So technically, even though I have big 100 amp Daly BMSs on my packs, technically the balance function never kicks in. So that is why I occasionally use external balancers. You have to read the specifications. Most BMSs are top balancing, meaning they balance when they get right up to that 4.2 volt mark. And so if you're sort of just slightly undercharging your batteries like I do on my Powerwall, your BMS will never kick in. So, your balancing will never kick in. So anyways, let's put this on charge and let's watch the ISDT and let's see what happens. Okay, so for now, I've just hooked up a 29.4 volt, 2 amp power supply. I was going to use I was hooking up my variable power supply, which I have over here, but I do worry about how many amps that thing is going to throw at the battery. So I think I'm going to, for now I'm going to use this. Now the problem with this is this auto shuts off at 29.4 volts. So we'll have to see. I do want this to slightly overcharge because you can see some cells have already hit 4.2 volts. Well, one cell is, the one cell that was really low, it's still coming up. I really want to see, what the BMS does as far as voltage cutoff and balancing. Because these cells were not in balance when we started this process. So is it going to, will it cut off when we hit say 4.3 on any individual cell? Or is it going to go into balance mode? The problem is it only balances at 50 milliamps. So, there's 2 amps coming in. So, what's it going to do? Or is it just going to let some of these high cells overcharge and hit 3.3 or 4.3, 4.4 volts, while this one's still trying to get up to 4.2 volts. So we're going to let this run and we'll see what happens. So this is pretty interesting. This is 8 hours later. And this thing has been receiving current at 29.6 volts for over 8 hours. And if you look at the battery voltages, we are not in balance, but we're a lot closer to being in balance than we were. I don't know if you remember, there were actually multiple cells that were over 4.2 volts before. And now, no cell is over 4.2 volts. Most of the cells are actually in balance at about 4.17. There are a couple low cells that it's probably still trying to work on. But it does appear as though the balance feature is working. However, I want to point out, this is only one cell per parallel group. And it's been working on this for over 8 hours. And it's only made a slight dent in the balance of these cells. Meaning, if you are relying on this to keep a large power wall in balance, it's unrealistic. This thing's only, remember, this thing I think was rated at 50 milliamps of balance. 50 milliamps could balance a single cell in maybe 24 hours. But when there's, 20 in parallel or 80 in parallel, like my power wall, it would take a month of just constant voltage and balancing to get it in balance. And again, that is why I like external devices like this that can balance quicker than the BMS. But this BMS is balancing, but I wouldn't rely on it as my primary means of balance, just because it is slow. And if you're using your device every day to charge and discharge, the cells will unbalance quicker than this can balance them. Okay, so let's test the maximum voltage cutoff of this BMS. This meter is in line measuring amps, and here's the individual cells. So the cells are not quite full. They're nearly full, but not quite full. And we're currently pulling 0.16 amps, and this is at 28.9 volts. Now, watch what happens when I take the voltage up a little. As soon as I hit 30 volts over here, 0 amps. And what has happened is the BMS has detected an input voltage higher than the top charge of these cells, and it has turned off the charge current. So the BMS did exactly what it's supposed to. Now, it is interesting that it didn't wait for the cells to start to, it didn't let the cells charge up to over 4.2 and then kill the current. It killed the current the second it saw more than what the top end of this battery pack is. So the BMS did exactly what it's supposed to. Now, if we bring that voltage down a little bit, 29.1. Oh, too high. This is very sensitive. There we go. You see, once you bring the voltage down low enough, the BMS turns back on. And then if I can just nudge this up just a hair. 29.2, and now we're pulling half an amp to charge these cells. So the BMS does exactly what it's supposed to do on the top end, and that's just watch for over voltage and turn off the current. Okay, quick change of plans. To discharge this, I've actually jumpered this battery onto my solar generator, and I've actually used croc clips to connect it to the inverter, which this is a 7S pack and this is a 7S solar charge controller, so I can run this right into the solar charge controller. And then I'm actually powering an LED light off here, pulling 22 watts, which is perfect to run this down. That'll take an hour or two. And the nice thing is I actually ran this through the shunt. I put the negative through the shunt. So actually the meter is working. So I can see the voltage we're at, how many watts we're pulling. And so we'll jump back when we get close to that 21 volts, and we'll see, does the charge controller shut down? Does the inverter shut down? What's shut down first? But, and then we'll, take it even lower on the inverter. Okay, so the solar generator has shut off. Now, we don't know if the BMS killed it or if the inverter killed it. So we need to check some voltages here, but it probably is actually it's probably the BMS that killed it, because I noticed the meter is off. If this battery was still on but the inverter had just shut off, the meter would probably still be running. The fact that the meter is turned off probably means the BMS killed everything. So that's good. And let's just check the voltage of this pack and see how low we got. In fact, I can actually plug this in. Interesting, we're at 24 volts. Now that's probably recovered, but I wonder, 24 volts is a bit low, but it would have recovered after it shut off. But let's try turn it back on and see what happens. Okay, the system is back up. The light is back on. We are running down again. And it's probably time to put a voltmeter on the battery, or I guess we can actually just leave this on. Ooh, interesting. Look here. A single cell has dropped to 2.8 volts. The BMS is probably going to kill the pack because a single cell is down to 2.8 volts. Not because the overall battery voltage has gotten too low, but because a single cell has dropped below 2.8 volts. I bet you that's what killed it earlier. Watch this, look. The BMS has turned it off officially. That's it. The inverter, it's not the inverter that turned off. We're above the inverter's overall voltage. The BMS kicked in because a single cell got below 2.8 volts, which is amazing. That's exactly what we want. Not only is it going to cut off if the overall the overall pack voltage gets too low, but even better, it cuts off when an individual cell gets below 2.8 volts, which is really, that's really important. So I'm very happy to see that the Daly is smart enough to monitor individual cells and the overall voltage, and actually cut off when the one individual cell was getting too low and misbehaving. It killed everything. So that's good to know. I like this BMS. It's doing exactly what it's supposed to do in all testing. So just remember, there are many BMSs on the market. Daly is probably the most recognizable of the cheap BMSs. So when you're buying BMSs, I would probably stick to the Daly for, you know, e-bikes and small power walls and solar generators, and that's probably what I would stick to, since it is a known brand, tested, and definitely seems to be working.